This is the Math 2 lesson summary video for the lesson entitled Algebra and Functions. In Lesson 9 of Unit 6, Algebra and Functions, the purpose of this lesson is for us to solidify our knowledge of extraneous solutions, and we will continue to practice algebraically solving equations that involve both a square root and an inverse variation function. In Lesson 9 of Unit 6, Algebra and Functions, we are looking at a linear function set equal to a radical function. Recall from our previous lesson that whenever we have a radical function, it is possible for us to have what we call an extraneous solution. So we are told that we need to solve where the linear function x minus 1 is equal to the square root function 2 times the quantity x plus 3. So what we did is we plugged in f of x in for y1 in our graphing calculator or Desmos, and g of x in for y2 in our graphing calculator or Desmos. And we were given the graph to the right. The green is the radical function, and the blue line represents the linear function. If you notice visually, these two functions only have one intersection point at the point 5, 4. So let's talk about the domain for the line. If you look at the line, the x values for the line go infinitely to the left. So we would say that the domain is negative infinity. And because the line goes infinitely to the right on the x-axis and keeps going, we would say that infinity would be our upper limit for the domain. So now let's talk about our range. Our range is our lowest to our highest y value. Well, notice the line keeps going in both directions. So for a line, our range should also be negative infinity to positive infinity. Let's talk about our green graph or our square root function. For our domain, we want the lowest x value possible. Notice right here, our lowest x value is negative 3. Therefore, we would use brackets. Brackets represent equal to. So negative 3 is our lowest. And our highest x value, notice this keeps going, so we would say infinity with a bracket. Now let's talk about our range. Our range would be our lowest y. So notice our lowest y is 0, and it is equal to 0. And our range would be positive infinity on the y-axis. So it would look like this. So we know visually by graphing that our solution should be 5, 4. But part of this task is also to practice solving a linear and a radical function algebraically. So let's take a look at this function. We know that the first step is to get rid of the square, so square root. So we're going to square both sides, so that on the right side I'm left with 2 times the quantity x plus 3, and that equals x minus 1 written twice, which is the quantity x minus 1 squared. When we distribute our two binomials, we should get x squared minus 2x plus 1 equals 2x plus 6. Let's combine our like terms to get all of our like terms to one side. We will be left with 0 on the right equals x squared minus 4x minus 5. Now this is a quadratic function. If you think back to Unit 4 and 5, we do need to see if we can factor that. And so we do have two numbers that multiply to negative 5 and add to negative 4. Those numbers are negative 5 and plus 1. Recall that we set our factors then equal to 0. And we solve. So our solutions here should be x equals 5 and x equals negative 1. Now remember, once you find x, especially if there is a radical involved, which in this case there is, we do need to plug in our x values into the original function, both functions, to see if they check. So let's do a check over here before we try and find our y values. I'm going to start with 5. I need to make sure that 5 minus 1 equals the square root of 2 times the quantity 5 plus 3. 5 minus 1 is 4. And the square root, that's 8 times 2 is 16. The square root of 16 is 4, so 5 checks. So let's now check the negative 1 works. Negative 1 minus 1 must equal the square root of 2 times the quantity -1 plus 3. -1 minus 1 is -2, and that needs to equal the square root. -1 plus 3 is 2, 2 times 2 is 4. But -2 does not equal 2. Therefore, we would say that -1 is not in a solution, it is extraneous. Once we know x is only 5, we will now plug 5 in to one of our original functions to get y. So algebraically, we'll use the square root function, that's perfectly fine. 2 times the quantity 5 plus 3, and we actually already know what that equals. The square root of 8 times 2 is 16, so we now know that y is 4. So our solution to this line and this radical function is the point 54, which again we can visually check in our graph above. So let's go back and solve a function where we have an inverse equal to a line and we need to find the solution. So looking at number 7, we would multiply both sides by x to get rid of it in the denominator. So 2 equals, I'll distribute my x, 3x squared plus 5x. When we subtract 2, we would get 0 equals 3x squared plus 5x minus 2. Recall to factor this, we can multiply a times c, which would be -6, and we need two numbers that multiply to -6 and add to 5. We already know that our two values in our parentheses would be 3x and x, so that they multiply to 3x squared. So when we think about our values, we could get -1 and 2, +2. If we redistribute that, we would be left with our original function, 3x squared plus 5x minus 2. When we set each of our factors equal to 0 and we solve, our solutions would be 1/3 and -2. So let's try number 13 now, where we're given a square root function and a line. Recall, to get rid of the square root function, you do have to square both sides. So we'll be left with 4x equals the quantity 2x plus 4 times the quantity, -2x plus 4. We're going to distribute our two binomials. We'll get 4x equals 4x minus 8x minus 8x plus 16. When we combine our like terms on the right side, we will get 4x squared minus 16x plus 16. Bringing the 4x to the other side, to get 0 on one side, we will get 4x minus 20x plus 16. We do have a GCF here, so we'll take out the 4. Sorry, that should be an x squared. My apologies, because an x times an x is an x squared. We will have x squared minus 5x plus 4. Factoring that further, we will have x and x, and two numbers that multiply to 4 and add to -5 are -4 and -1. So therefore, when we set x minus 4 equal to 0 and x minus 1 equals to 0, x should be +4 and x should be +1. Now remember though, we have a radical function. So we do need to check if there are any extraneous solutions. We could also visually check this by looking at a graph. But let's plug in 4 first into our original equation and see if it checks. So this is the check for number 13. The square root of 4 times 4 needs to equal -2 times 4 plus 4. The square root of 16 is 4, so 4 should equal -8 plus 4. And -8 plus 4 does not equal 4. Therefore, 4 is an extraneous solution. Let's try x is 1. The square root of 4 times 1 needs to equal -2 times 1 plus 4. The square root of 4 is 2, so 2 needs to equal -2 plus 4, and it does. So therefore, my only solution in this case is x equals 1. If you need more help solving a radical function in a line or an inverse function in a line, please check your Canvas student support site.